Hi guys, thought I'd do a quick little video here on the latest acquisition of lithium ion charge and 5-volt boost boards. These things I tend to use on my projects when I need to, I want to run them off one lithium ion cell, but I need 5 volts and not 3.7 to 4 volts or whatever they output. So these boards over here allow you to use one lithium ion cell and boost the output to 5 volts for my project. This one over here is the one that I have been using for a couple of years. I last bought a batch of these in 2021. I just had a look on Amazon. This thing here is based on a well-known chip over here. It's usually marked TP4056 or LN4056 or LM4056, whatever, because it's been around for a while. There's many manufacturers that make them, including several in China, and they work well. They just do a good job, charging the cell. Got some little LEDs on there that shows when it's charging and when it's complete. This section of the board over here is the boost converter. Takes the voltage from the battery and turns it into 5 volts. It's of course a switch mode converter, so it has the requisite Schottky diode here and an inductor, and it has a little trim pot here to adjust the voltage to the exact voltage that you want, 5 point whatever, 0 volts. The only problem with these is that those little chip capacitors here are not up to the task of filtering the switch mode pulses out, and it will have quite a high ripple voltage. But if you hook a good electrolytic capacitor or a solid aluminium capacitor or a tantalum capacitor on the output of it, I've gotten the ripple down to like 20 millivolts or something like that, which is quite acceptable. So these ones, as far as I'm concerned, they can be made to work, and you will see they are available. This is on Amazon here. That's the last time I bought them. That's the ones. There are probably some others on Amazon. You probably have them on AliExpress. I don't know, but that's what they are. This actually tells you that TP4056, and it's got an MT3608 boost circuit. That's the little chip that's on there, and inputs 4.5 to 8 volts for charging, and output it says 4.3 to 27 volts adjustable. Now these guys over here, this one is a little board that actually comes with a holder for the lithium ion cell, and it comes from AliExpress. There are many different versions of this with different layouts. If you look at them, this particular one I got because it's got a USB-C charge port on it, which is what I'm trying to I hate those micro USB things if I can avoid them. And it has again 2 sections on this board here. This is the charge section, and this is the actual boost section over here. And again, from what I've seen so far, is this is an ordinary cheap electrolytic, I think, capacitor, and the ripple voltage is higher than I'd like to see it. So no doubt if you're going to use this thing, you also have to hook up a better low ESR capacitor or some sort of filter circuit on it, maybe even including a little inductor or something. But other than that, it seems to work okay. We will have a look at that, of course. These two over here, this one actually comes with a little USB-A socket that actually mounts at the bottom of it, which is in fact what I've done to it, but you can use it without. Of course, you can take the outputs over here on those little pins as well and just ignore that socket. And these things come on a chip which I hadn't seen before, which we'll have a look at, and it is unclear to me what that chip was actually designed for. I think that chip was actually designed for a little power bank or something like that. It has some peculiar capabilities, features. I don't know what else to call them, but I don't think that these boards are very useful except for some very specific instances. And you might notice this one has a little button on it, and that button is actually needed. This one over here actually brings out a little pad over here with a K on it. This is all not documented. This is stuff that I have actually determined, which you would hook the button up to. So we'll have a look at that and discuss that further. So this is the other little board that we have there, and what has had me fooled is, you see when you look at these pictures here, got a chip on there that says MHCD42, but that's not the chip that's on there. The same goes for the other one. Anyway, it says 2 amp, 5 volts, charge, discharge, integrated, 3.4 volts, lithium battery, boost, mobile, power protection, da 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 da. So I thought I would give it a go, and charging voltage 4.5 to 5.5 volts, current 0.2 to 1 amp, charging quiescent current 100 microamps, full voltage 4.2 volts. That's for the battery, obviously. Discharge current 0 to 3.5 amps. Good luck with that. 50 microamps when this is just hooked up with no load on it, I guess, and it's turned off, and so on. Has a charging input, a couple of grounds, battery, and key, output enable trigger port, low pulse trigger. That's actually this button over here, but you can solder a wire to it as well and do it externally. In discharge mode, the charging mode key function is invalid, blah blah blah. This stuff is hard to interpret. It is badly translated from Chinese, obviously. They're like flashing says falsing. This is how you hook up the thing. And so on. So that's the one. Okay, here is the other one. Then if you look at the pictures of these things, like it has the chip says hot chip PD0063A. Again, that's not what's on there. It's exactly the same chip as the other board we just looked at. The difference with this one is that it doesn't have the button on there, but it's got this little pad here with K on it as well, where you'd have to hook up a switch. So what actually happens is with these guys is that the charging works very well, and shows you 25, 50, 75, 100% charge, little LEDs on there and stuff like that. But the output voltage And on this particular one, this is like, it's got that optional socket there that you can mount there, or you can just get the voltage from those two pins over there. Is that if it draws less than, I think it's like 50 milliamps or something like that, it just shuts itself off. And it's supposed to have an automatic start mechanism. Like if you plug something into that USB socket, for instance, which you'll see when we try it out, 8 out of 10 times, depending on what you're plugging into it, it will start. And if you're drawing more than like 50 milliamps or something like that, it will keep running, and then that's fine. Again, the actual ripple on it is quite high because those, as I said with the other ones too, those little chip capacitors here, they are just not good enough for filtering out the ripple. And of course, if you're using it with a USB socket, there's little option to hook a little bit of extra circuitry up to it to filter out the ripple. So you would be better off actually to get it off these two little sockets over pads over here, and hook up a capacitor or something like that to do some more filtering, whatever. So that is what that one is. Again, on AliExpress. And it says FM5224G is a mobile power supply that integrates lithium battery charging management, battery boost output, battery power judgment, and LED power indicator. So I get the impression that this device, it was simply made for little power banks, and for that it probably works quite well. Those little boards, it's not useful for putting in your little projects. This is what I'm trying to say. And again, see, there's the little switch over here that actually sets it off if it's not automatically starting when you plug something in. And some diodes, an inductor, a capacitor, and the USB jack out, which is pretty much that one of those little boards along with the switch on it. They have exactly duplicated this, except they don't have this little LED and the 100 ohm resistor on there. Then of course, there is some sort of diagram here which I can't read. If anyone of you knows what that says, because you can read Chinese, put it in the comments and maybe you can work it out. But anyway, that's what we're working with. Okay, now this one over here, using that view, this little board over here is that's the one that came with the little battery holder for a 18650 lithium ion cell. Boost board description: boost part of the use of switches to control its work and shutdown. Now, if you can interpret what that says, you're better than me, but what it actually means is that you need to put a switch on it for it to work. And if you look at the comments, a lot of people bought these things, hooked them up with a battery and saying, hey, there's no output, it's not working. I wonder how many of them get returned because they don't explain that you need a switch there. It says the switch needs to be equipped with its own. Translation: you need to supply your own switch and mount it on the board before it will work. Anyway, that is what it looks like. See over here, those two pads, you either got to put a solder link over there, then it'll work all the time and it'll never be switched off, or you can just put a little switch on there. Okay, so I have this guy connected over here. I put a lithium ion cell in there. This is quite an old crummy one. because I want to see what it does, you know, with low performance stuff. The switch is on, the little light here is on, that means that it's producing output. And in fact, you can see at the top right of the screen there, we're having 5.18 volts. Oh, I have the wrong multimeter is connected back to front. There we go. That's more like it, 5.18 volts. And on the oscilloscope, all I'm drawing right now is I've got to connect it to the electronic load. It's 50 milliamps, and we've got some nasty spikes over there, which kind of shows, you know, that the filtering is not going to be great. And on average, we've got 45, 46 millivolts of ripple already. So let's have a look what happens when we increase the current. We are at 100. It's hard to nail these things down, but that is what we've got. Move it up a little bit. So let's reset the statistics. A little bit higher, we're at 48 millivolts. So let's give it 300 milliamps. Now we are starting to see that we have almost 100 millivolts of ripple. Half an amp. And as you can see, we have 192 millivolts. Totally unacceptable. This is at 700 milliamps. It's supposed to be able to go up to an amp on that thing, but I'm not going to take it that high. So let's have a look if we can tone that down. Actually, at 0.7 amps, it looks like it can't actually supply the right voltage. I just noticed it's 2.6 volts. So maybe, as I said, this is not a very good battery. So let's have a look what happens when we switch the battery to a better one. Okay, this is better. Now it can keep up with the voltage. So let's have a look now. What's happening to our ripple? It looks that has improved as well, by the looks of it. Let's reset it. Not that much. 167. So what happens if we put a low ESI capacitor on there? See if I can do it. Just holding it on there, see what happens. Because if it was soldered onto the circuit properly, it would be obviously a lot better. Well, that has made an improvement, but it's still at a 100 odd millivolts. Yeah, if I hold the capacitor tight onto the pins here, 80 millivolts. So this is indicating that if I was to solder a low ESI capacitor just across the output there, that it would become a lot better. And with a proper battery that can sustain the current, this blue one obviously can't. We are in business. Anyway, that is how this thing goes, and I don't think there's any real problems with it. But as I said, I would add some extra circuitry here on the output. This is a solid aluminium low ESI capacitor, but I have some others there that might even be more. One of those tantalum chip capacitors probably would do a good job there. Anyway, that is what this thing does, and you can switch it off, and you can charge it through that port there. And there's my okay. So I've got it switched on. I'm drawing. Let's draw half an amp, which is more reasonable for when I'm using it in a circuit, you know. 5. Well, actually, for interest sake, this is 1 amp, and it can obviously do it. It's rated up to 1 amp. It's still 5 volts. So this is half an amp. And now what happens when I plug in the charging circuit? The light comes on, and I believe it is now actually this is indicating that the battery is fully charged. The green light came on. And, I think when you plug this in, you actually get the charge voltage, and I have it plugged into a PD 65 watt charger port, so it probably has, let me see now, yeah, 5.3 volts. It says 1.5 amps. It is drawing 1.4 amps. In any case, I think this guy here is workable for my project. You can put the on-off switch right connected to those pads. So I think this one is a goer. Okay, so I've got this little board over here with that FM chip on it connected, and this is the one with the little switch over here. I'm not going to bother to do too much with this one because the other board has the same controller on there and a very similar circuit. But when you first plug it in, as you can see, the output has only 2.3 volts. And if you try to draw current from it, it goes into some sort of strange oscillation where it oscillates from 0 volts to 2 volt, 2.3 volts, and what have you. I do not know what that's all about. If I push this now, let's turn on the electronic load, and let's set it for 300 milliamps to start with, or maybe just 100 milliamps. Just see what it does on the low current there. And I'm going to switch it on. It says it is supposed to automatically start when it detects a load, but obviously not when the load is 100 milliamps. it'll slowly build back up to 2 point something volts there. I'm going right up to 300 milliamps now. Turn it on. See, nothing. So then when you push the little switch, all 4 lights come on, and then you will get 5 volts out. And the little lights will dim in a minute, I believe. And from there on, it will keep on producing 5 volts, but it also has quite a lot of ripple. We'll see that on the other one. I'm not going to test this one. But when you plug in a charge current on this particular one, I am going to plug it into this. See, now it's indicating that it is charging, but look what happened to the output voltage. Let me dim it down so you can see that the last little LED there is flashing. Seems to overload the camera. But now it outputs 4.6 volts instead of the 5 volts. If I unplug it, it just turns itself off, and it'll just flash like that. As I said, it does some weird stuff. If I push the button again, now it won't, after charging, it won't start anymore, even if I push the button. As I said, these ones with that particular control on there, they do weird stuff. Let's try the other one. You'll see it'll behave pretty much the same way. But in that one, we can actually look at the output. Okay, so this here, we're going to do something slightly different. I've got this device here with a little electronic load on it. Come on, stop changing the screen on me. We're going to be trying this little board here. Remember, this little board doesn't have a switch on it, and it's got the same chip, the FM53, whatever it is. Hard to read, like I showed before. So for testing, I hooked up one of these little batteries that I salvaged out of a device, and this is going to be the power switch. This is something I had laying around, and I actually hooked up a little switch over here on this little board to that K port over here, which is the actual, because this board doesn't have a switch, and I've plugged it in, but it's because it's upside down, and I soldered the USB connected to it. And that's why I'm using this device here, because it's easier to, it's got a little electronic load in it as well. Alright, so now if I can remember how to use this thing, there's a switch there. So first of all, let's switch it on. And again, when you first switch it on, it's only got 2.5 volts, and you can see how it is kind of 2.9 volts rather, this one, and it's just, it's going through, it's not working. Now when I push the switch here, now there are some little lights that came on it, and now it's at 5 volts, and we are drawing 0.3 amps, third of an amp, and but I've got to push start. There we go. So now it is drawing 0.3 of an amp. It seems to be able to do that. Okay, so let's throw half an amp. But in the meantime, you see it has switched itself off. So there's no voltage. Now it is supposed to be that if you, when we start it, you plug it in, it doesn't auto start. If you stop the load and you plug it in, still nothing. So it doesn't have that switch on there, but you have to hit the little switch before it will output 5 volts. And now it is able to do it. So again, what is this thing useful for? As I said, it's on a little power bank where you can put a switch on it and a little LED. There is actually a little LED in the switch, and it is wired in, but it's not lighting up because the voltage on that thing is too low. With the 100 ohm resistor on there. On here, there's a little yellow LED in there, and the voltage is not high enough that it produces. Going half an amp, and we have 40 odd millivolts of ripple, which if we put as I said, a capacitor across there, that could be reduced. So while it is running, it is not doing too bad a job, but it has that weird shut-off function, and it makes it kind of useless for some applications. Anyway, so that's what we've got. Okay, so the end result is that this one will work with a little bit of extra filtering. So does this one, the older one that I have. So these two over here that are based on that FM5324 Chinese chip. No good. Don't buy those, they are useless. Anyway, that is what we've got. If you like these videos, so we test some of these things. Make sure you subscribe and like and all that kind of stuff. And I will see you guys in the next video.